Bhandari. I welcome you, sir. I hereby also welcome the eminent speaker, Dr. Harpreet Kaur, British Columbia Institute of Technology. She is working there, faculty member, Canada, faculty member from different part of the country. We have received more than 500 entries and registration from the different part of country. Last but not least, the research scholars or students from the different part of country who have joined us to grace the webinar. We are thankful to them. I formally welcome here to the DBT sponsored International GRIT KARYASHALA on the topic how to learn mathematics in a meaningful way. So now I request Head of Department of Mathematics, Arvinanda sir, over to you.
Esteemed Principal Sir, today's resource person, Dr. Harpreet Kaur, members of department, and dear students. I welcome you all on our webinar on how to learn mathematics in a meaningful way and be successful in it. Our speaker and resource person for today, Dr. Harpreet Kaur, is a faculty from British Columbia Institute of Technology, BCIT, Canada. She has been awarded by Simon Fraser University for Travel and Minor Research Award in 2014 and for Vancouver East Rotary Graduate Scholarship in 2030. A skilled researcher and analyst in both quantitative and qualitative approach. Dr. Harpreet has worked on projects of developing geometric thinking in young children and tangible mathematics learning. We are thankful that she accepted our request of interacting with students. I hope our session will prove fruitful for them. Today's session has been made possible by initiative of our principal sir. His vision of teaching students not only in theoretical approach, but also through practical applications has made this session successful. I thank him for his constant support and valuable insights to our mathematics department. Once again, I welcome Dr. Harpreet. Now I request our principal sir, Dr. Pradeep Bhandari, to say a few words. Thank you.
Thank you so much. First of all, I would like to welcome the esteemed gathering from various parts of the country and especially the resource person of the day, Mr. Dr. Harpreet Kaur. Though she is from British Columbia Institute of Technology, but in the morning I learned that she has her roots in Jalandhar itself. So Harpreet, welcome to Jalandhar. So we'd like to have you in Jalandhar, in our campus, whenever the things improve. And whenever you come to your place in Jalandhar, do come to Jalandhar. So we'll be waiting for that day, that happiest day. So I was going through the CV of today's resource person. She's really learned personality, PhD from Simon Fraser University, Canada. And the most important thing which impressed me a lot is that her study is related to the applied aspects of mathematics. And she has worked in and vast experience in robotics, mechatronics, mining, health. That is really impressive because being from computer science background, I can understand what effort she has put in the nitty-gritties of mathematics to apply those concepts into these topics in vogue, especially mechatronics, because the mechanical in our region there is only one institute in Patiala which is offering this course in mechatronics, and she has already worked on it, where the mechanical and electronic parts are being clubbed together and a new field for us. In fact, maybe she is teaching this field for many years, but in India it's relatively new. So I will request her that in future please throw more light on these practical aspects, so that our students who are relatively unaware about these practical aspects of mathematics. So mathematics is known as mother of all sciences, but still its application, when we come to its application, we are sometimes feel handicapped. For example, while I was pursuing my PhD, whenever that Fourier transformation and other things came, it was difficult for us to understand. So today is a great opportunity for all the faculty members and students from various parts of the country to have a glimpse and to understand those things in a simple way. Because what I understand, the difference between a simple teacher and an expert is that expert can make us understand complex things in a very simple way. So I hope Dr. Harpreet will be teaching us nitty-gritties of mathematics in such a interesting and beautiful way that it will seem as if there is a point in mathematics we are listening to. So it's going to be a treat for us. And I once again welcome Dr. Harpreet and all the participants. And I have just seen Professor O.P. Arora.
Yes, sir.
Participant list. Welcome, sir, to your own college. There are other teachers also. It will not be possible for me to name everyone because it will take a long time. We have such a distinguished gathering in this seminar. It will not take much of your time. I again welcome all of you in Doaba College, Jalandhar, and especially congratulate our Department of Mathematics who have taken such a pain in this difficult time and make it possible for us to learn, to listen to see the most academically strong resource person of the day, Dr. Harpreet. Thank you.
Thanks, sir. For you. Yes. Dr. Harpreet, you can carry on. That's now I thanks, sir, for your inspiring words, and I would like to share one thing with all the participants that this workshop is brainchild of our principal, sir. Sir has encouraged us and give motivation to go for it, and this credit goes to principal, sir, and we are really thankful to you, sir. And I want to tell you that Doaba College is the 80-year-old college, and you are here, and I welcome you in this multi-faculty, multi-dimensional premier institute of Northern India. At Doaba College re-accredited with the A grade by the NAC, college with potential for excellence accorded by the UGC. Our inspiration is Swami Dayanand Saraswati ji. And these are some achievements of Doaba College, recognized with college with potential for excellence by UGC, DBT Star College, Department of Biotechnology, Ministry of Science, Technology, Government of India, New Delhi. And other achievements of our institution is the only government-aided college in Punjab having star status by Ministry of Science and Technology, Government of India, New Delhi. Presently, 14 undergraduate courses and 10 postgraduate courses and 6 add-on courses are currently running successfully. These are the glimpses of auditorium of Doaba College, having capacity of 1,000. This is the open-air theatre of Doaba College. And this is the postgraduate department of Doaba College. And one more thing I want to share with the participant that the renowned director Yash Chopra ji is alumnus of Doaba College. And there is a Yash Chopra TV studio in our institution. There is a gymnasium, lush green grounds, and separate hostel for boys and girls. And this is a great college and serving the society from the last 80 years, and it is enjoying its academic excellence. Now, I want to share the objective of this conference, why we have gone for this one. Just a minute. That we are thankful to the DBT for providing us platform to strengthen the mathematics skills of undergraduate students. And we have maintained this objective of this workshop is to improve the teaching learning experience of undergraduate students, improve student confidence toward the problem solving, self-learning, communication skills, and capacity to work in teams. Basically, when we see the research-based pedagogy, these are the 6 steps. First, we inspire, then we make idea, then we work on that idea, and then we refine that idea. And after refining the idea, we report about it, and then we publicize that results. And I want to tell you that this workshop is the first step toward that direction. This already we have started a MATLAB series, and the first lecture has conducted on 31st March. And in order to give students the practical experience, a computational mathematical laboratory is in final stage of completion. That is also sponsored by DBT. The only purpose of our college is to give students the practical experience. Now I request Dr. Harpreet. Before you, Professor Harpreet, I invite you for the talk. I want to give the brief introduction of Dr. Harpreet. Sure. Just a minute. Dr. Harpreet, just wait for a minute. And I want to give the brief introduction of Dr. Harpreet. And Dr. Harpreet is a gold medalist. She has done MSc 2007, and then she has done PhD from Simon Fraser University. And she got awards, Travel and Minor Research Award 2014 from Simon Fraser University. And she received East Rotary Graduate Scholarship 2013, President PhD Scholarship. And the paper, you see that she taught technical mathematics for robotics, technical mathematics for mining. And then she has developed, she has worked as research assistant, and she has developed a powerful geometrical thinking in the young children. And we have seen that in mathematics, the basic problem is in visualization. Once you start visualizing the things, you start learning the subject. And she has done a great work there. And she has also expert in LMS. She can work on Canvas, DL2, and she is expert in mathematical and statistical software. And now, Dr. Harpreet, the podium belongs to you. Now, screen is up to you. Then you can present your screen. And I want to tell you one thing, that our ex-HOD, Professor Om Prakash, Professor Manmohan, Professor Dwinderjeet is also there. And all the worthy members are also there from Doaba family. And there are more than 500 registration across the country. And you will be glad to know that there are people from South India, Maharashtra, Bihar, and the people are also from IIT Delhi, IIT Dhanbad. And you can see that there is ocean of intellectuals. And the only target is to give our undergraduate students something they learn, so that they can bridge the gap between the undergraduation and the PG research. This is the basic of the new education policy of 221. And we have kept that theme in mind. Our principal sir is also working on the same theme to make our student employable. As you told in our conversation, that the institute in which you work, the placement rate is more than 80%. And that is really great. And we also want that our students also get employed and do work for nations and solve the problems. As today is Environment Day, I wish you all the Environment Day also. And now mic goes to Dr. Harpreet. Now it is up to you.
Thank you so much, everybody, for joining in tonight. Actually, I should say morning, because it's night here, so that's why I said tonight. I'm sorry. It's really wonderful to be a part of this session today, and I really thank everyone for such a warm welcome. Thanks to all the faculty members, all the students, all the big scholars that have joined in tonight. So I will try my best to do the justice to my session, because I was under the impression it's just for undergraduate students. But I'll make sure that everybody takes a piece or two from this session that they can feel is useful to them. So you guys said so many great things about me, so I'm really humbled, but I don't think I'm that great. Anyways, let's start today's talk. So during our talk, I'll ask a few questions to you guys. If you feel comfortable, you can type your responses in the chat. But no pressures, as I always say to my students, no judgments, no pressures. So if like you want to respond to my questions, you can do that in the chat. All right, so I'm just gonna go ahead and share my screen. And I hope my computer doesn't freeze when I do this. Okay. All right, so today's topic is how to learn mathematics in a meaningful way and be successful at. And before I start, am I like clearly audible to everyone? Again, you can tell me in the chat. Yes? Okay, perfect. All right, thank you so much. So as you guys know that I teach at British Columbia Institute of Technology. It's been 3 years of my teaching career. And today I'll start with my personal background, and then I'll talk about my professional workplace and 2 things about BCIT where I teach. And then we'll move to our main topic of today's seminar, which is strategies for better understanding and retention of math. And I'll also try to make this workshop a little bit more practical. As I always say, like, we should pay attention to the practical aspect of mathematics. So I'll try to introduce a few free resources that you can use as students to help your, to make your understanding of mathematics better, or even as a teacher, so you can use those resources in your classroom. So, and in the end, I'll discuss what is the main point that you should take away from today's session. So I'll conclude my session with that. All right, so basically I was born and brought up in Punjab, and I'm from a very small village. It's in Kapurthala. So I did most of my schooling from India. So as I know, like, there are many undergraduate students in this session. So I was once in the same place as you guys are. So I was in the same seat. So I did my BSc from Kapurthala, and then I did my MSc from Jalandhar in 2007. And there were some strategies that I used at that time, and that helped me to be a university gold medalist. And I think anybody can do that. It was like really very simple strategies that I'm going to tell you. And then I did my B.Ed and M.Ed from Chandigarh. And then eventually, like, destiny brought me to Canada. So that's another story, like how I went to Canada. So I never planned to leave India, but it just happened. And I'm a proud mom of 2 little kids. My son is 4-year-old and my daughter is almost 6. So yeah, so they are pretty handful. So I'm quite a busy mom as well as being an educator. And so you guys can relate with me. So my professional journey, so during my PhD, I got a chance to work as a sessional instructor at SFU. So that helped me to get some Canadian teaching experience, as well as I was working as a research assistant there. So the one thing in a foreign country is if you have qualification and experience on your resume, only then you can get the job. So when basically I finished my PhD, I already had a few like things on my resume that helped me to get my dream job. So BCIT is very close to my home. It's just like 15-minute drive. And we don't have many like colleges in Canada because the population is not that much. And there are very few academic jobs. And I was very lucky to get this job. So I think it was God's plan for me. And I'll talk about a few things that I like about BCIT and that I learned here that were different from my own teaching, own learning experience. So BCIT is different from any other colleges or universities. So it doesn't offer you just the theoretical knowledge. It basically focuses more on the practical and applied education. So every year we enroll like more than 50,000 students each year, and we have approximately 2,500 employees at BCIT. So it's a pretty big polytechnic college. And by the time students graduate from BCIT, they do have those real world skills and practical experience that makes them fit for the job from day one, like without any training and stuff, because they do lots of hands-on things on campus in BCIT. So our college is distributed into different schools, like we have School of Business, School of Energy, School of Health Sciences, Construction and Environment, Transportation, Computing and Academic Studies. So I work under Computing and Academic Studies, School of Computing and Academic Studies. So because I'm a math instructor, so we get a chance to work with all other schools. Because if in the School of Construction, we have civil engineering, or we have like a CAD drawing, like we have many different courses, or we have environmental sciences, we have chem and environmental engineering, mineral exploration program, or we have like aircraft maintenance engineers. So we have like very vast variety of programs in our institute. So School of Computing and Academic Studies, it gives a service to all other departments. So because math is like a main science, right? Physics is a main science, chemistry is a main science. So as math, physics, or chemistry instructors, we teach in all the schools, all the different departments. And I'll give you an example of like how our programs are made in BCIT. So basically, we spend less time on lectures and we spend more time in labs. So if I do 3 hours of lecture every week in a math class, like obviously it's like scattered around few different days, but we also do 4 hours of lab time for math. So it's really like hands-on. Like if we learn a math concept, we try to use this software so that we can put that math learning into the actual use that they're going to use in the industry. And we have so many labs at BCIT. We have robotics lab. For marine engineering, we have like simulators. Similarly, for aerospace engineering, we have simulators. We have a thermal power plant simulator. And like these are just a few examples, but it's like we have a very good infrastructure for all of our programs. And I know tonight's topic is not to advertise BCIT, but what I want to just show you guys that like how our programs are made at BCIT. So this is just an example of first 2 semesters of courses in mineral exploration and mining technology program. And if you look at the list of different courses, you can see that like I would like to highlight like we have math, right? So it's like math for mining. So we have similarly chemistry for mining, physics for mining, and even in the second semester, they do calculus for mining. So basically, the core concepts are the same, like whatever you guys learn, like rate of change, differential, like how to do the chain rule and all that stuff, right? So the core concepts are the same, but we put more focus on more problems that are actually related to mining industry. And all the other courses, you will see that they complement each other. And at the end, students do a project at the end of their program in which they have to put all the components together. So if you see there is like communication com 1135, so it's a technical communication course, and they actually teach them how to write letters in industry, how to make your resume, like for the mining industry. So it's very specialized program, and it focuses on just that aspect. And similarly, we have mechatronics and robotics technology program. And again, so when we teach them calculus for robotics, we actually like talk about the transformations and all that stuff that actually you need to make a robot, right? And similarly for technical mathematics, we do like phasors and stuff, like all the circuits and stuff in the math course, because that is related to your program. So this is just an overview, like how we do things here. It's a little bit different than what we do in India, but like some strategies that I think will be effective no matter where you learn. So even if you're just homeschooling or you're learning in a school, these strategies will be helpful. I just hope so. So first thing, whenever we learn something, we should prioritize conceptual understanding. Because most of students, even when I was a student, what was my goal? My goal was to get good grades, right? Or just like score as much as I can. And there was like so much competition between me and my friends, like, oh, I want to get more higher percentage, or I want to get a better position in university than my friend. So it was like not so healthy competition, right? There was a little bit jealousy and all that stuff. So you guys can relate to that. But one thing I learned over my teaching career or my student career, that it should be a healthy competition. We should help each other, because if I'm helping my friend, I'm explaining something, it will help me to learn things better, and then eventually we both will get good grades. And it's not like whatever job she is applying to, like you're gonna apply to the same job. So when you go out of the college, you go in different directions. You just don't go into the same place that there are gonna be comparisons between your grades. So just keep an open mind and try to focus on conceptual understanding. So if you learn an abstract idea in the classroom, so think about like how you can visualize that, like what does it look like? Because it's very hard to explain its abstraction sometimes. And I know like we come from very shy backgrounds, and we are always very hesitant to ask questions in classroom. So I always tell my students, there are no judgments, just ask questions, because that's what you're paying for, right? You paid to your institute, you're paying such a big amount of fees. You should get a good experience out of, like a rich learning experience out of your classroom time. So ask questions in classroom. Don't think that a question is a stupid question or a silly question. So if you ask one question, maybe 10 other students have the same question. It will help everybody, not just you. And always try to figure out something that you can help to visualize things. And I'll show you some resources today, which are absolutely free. And since everybody has cell phones nowadays, or tablets, or computers at home, so these resources are absolutely free. So just stay tuned for that, and I'll come to those resources very soon. So whenever we do some, like we learn a new concept in the classroom, we always say, sir, it makes sense when you explain it, but when I try to do the same questions in the exam, I don't know what happens. Like I do get the concept, but I don't know how to do the retention, right? So we tend to forget things. So rather than just blindly practicing the questions, or don't giving, like if you don't give too much thought to that, right? So if you just keep blindly like repeat the process and you think, oh, you got the thing right, but it's better to find like some real life applications of the topic that you learned in class. And it doesn't take much long. So maybe let's say you learned rate of change in the class today. Go on internet, go Google something like what are the uses of this rate of change in the actual real life? Like what are some applications? What are some areas where we use calculus? And even if you just do like 5 or 10 minutes surfing, it will give you something very fruitful. Like you will feel really like enthusiastic to learn the concept if you know where you use it. So try to do that. Not every day, so maybe just once a week, like whatever you learned throughout the week. So try to figure out some real life applications of that concept. And if you do homework, try to do homework in groups. Like if you want to practice, let's say 10 questions based on the topic you have done in the class, so try to do as a group. That will be really fruitful. And because usually in India, we think like everything is like in separate compartments, like biology, okay, medical students, there is no connection between medical students or non-medical students, right? It's two separate directions. But think about the things, like calculus is used in biology as well, like in many things, like if you think about rate of dissolution of drugs in the bloodstream. So whenever we eat a medicine or something, it takes some time to dissolve into our blood system, right? So we can figure out that rate of dissolution of the drugs using our rate of change concept. Similarly, growth of bacteria, or if we think about the growth of tumors in the body. So some tumors, they tend to have like a certain geometric shape. Like let's say, I'll just give an example soon. Like there is one tumor that particularly has like spherical shape, and we can see like how, if we know the radius of the tumor, we can figure out like at what rate of change of the volume of that tumor is in the body. So I have a question for you guys. If you want to answer that, you can. What is the derivative of 4 over 3 pi r cube? And you guys know that 4 over 3 pi r cube is volume of a sphere. I'm just looking at the chat if I get any answers. And you know, there maybe there is, it's hard to type pi, so you can just write pi if you want to answer in the chat. Okay, I do got some answers, but I got a very good question from Subrat. He's saying, please mention with respect to what? That's very good thinking there. So I just said, give me the derivative of 4 over 3 pi r cube. I did not specify with respect to what, right? So is it with respect to x? Is it with respect to t, like time, or is it with respect to r? So always, whenever you do a question, think about that question a little bit. So if you're doing with respect to radius, so that's correct, it's 4 pi r square. But what if I'm doing with respect to time? Then what it would be? Does it ring some bell about the chain rule? If I tell you that radius is changing with respect to time, or it's a function of time. Okay, so so then we can do dr over dt, but if it doesn't have any connection and it's not implicitly a function that is related to time, then it will be 0. Very good. Good work, everyone. I'm so proud of you. All right, so similarly, as I was talking, if we know that radius grows at a constant rate of k, and so it has a connection with time, and if you know the radius at any time, you can figure out the rate of growth of the volume of the tumor at a given radius. So you can basically figure out dV over dt. So how the volume is changing with respect to time. So I think we already covered that. That's right. So Ritik told us that it's, so if we try to figure out dV over dt, so I'm very afraid to use this pen on my computer because last time I tried it, it hanged my computer. So I don't know if it's a good idea for me to keep writing on this. And then you can plug in the value of your radius. And if you know that constant rate of change, you can put those values and you can see how the volume is changing, how the volume of tumor is changing with respect to time. All right, so that's one application. So as I said before, like we should do some group work with our friends because that helps us to learn better. And I know, so if you are studying under Guru Nanak Dev University, I don't know, like if it is applicable to all universities in India. So when I was a student, I knew if I do all the classwork nicely and if I do the all the, like what they call it, tenure, like where you have all the different last year's exams together, like they sell in the market, right? It's called tenure booklet, something like that. Yeah. So if you do that very thoroughly, not just like cram it, if you do that thoroughly, like all type of problems, if you just do some analysis of the problems, okay, so this topic has this sort of problems. And if you just do that, you can top the university. But of course, you have to do your work along the way. Don't just leave everything to the last minute. Whatever you do, do it thoroughly. So we used to do some group study sessions where we used to make notes about all those 10 years and then try to prepare ourselves for the final exams. So few things that I found that were helpful for me to explain. I don't know, I was a little bit good in math, and sometimes I used to explain problems to my friends. And I just thought like when I explain or when I verbalize my problem to others, like my reasoning to others, it gave me a clarity of thought. And like my retention rate was better. Like those were the things that I never forgot, which I explained to others. So because it created some sort of self-awareness of my own problem solving strategies, like what works for me, what doesn't work for me. And also sometimes they used to explain their reasoning to me, and then it helped me to grasp like how we can do one problem in more than one ways. Because you know that in mathematics nowadays we don't pay attention to what is the final answer. So it's not like if you get the final answer you get the mark. If you get like a different answer you get 0 marks. We also look at the process, right? How did you try to do the problem? If you do partial solution correct, you get the partial marks. So math is not just about one final answer. So you can use different approaches to reach that path, to reach that final exam answer. And if you do group work, it actually mimics the real world situation. When we go out in industry, like when we become professionals, how do professionals work? Like many team members together. If somebody has worked in a multinational company, they will know like when they make new strategies and stuff, they collaborate, they brainstorm the different ideas. So they work in conjunction with each other, right? So not just in like, it's not like one person is doing one thing and they have no like relation with the other people. So it's a good idea to do the cooperative or group learning, like group work, because research also suggests that if you teach others, it yields the highest rate of retention. So you will not forget those things that you explain to others. And sometimes a concept that is really complex, and when you try to explain it to others, you make it like easy for yourself as well, because you try to break it into different steps and or maybe in smaller parts, and it really helps you. And another thing is sometimes when we try to explain something to other person and they have some gap in learning, so it's always a good idea to go one step back. Like even if you are working alone, but you feel like, oh, I don't know how to factorize something. So maybe just go back to the factorizing topic, do few examples, try to learn that first in like rather than just jumping to the next level. So try to go back, just take a step back. That will help to better your future learning. So whenever you do a group study session, or even if you just do your homework at home, so just like take 5 minutes to reflect on what worked for you, what did not work, like what kind of problems did you face. Make some notes for yourself, right? So what strategies did you find helpful, or how being exposed to different ways of reasoning help you think in a better way or maybe in a different way. Or yeah, so you can choose your own favorite ways of learning. So in BCIT, like we try to give our students like some application problems. So this is one of the examples of a collaborative project that we gave to our students. So in the robotics program, they had to figure out how to bring a glass of beer over a linear distance of 10 meters without spilling the beer, right? So, and there were few constraints like how the velocity or position or the acceleration function should be. So they should meet all these conditions. And this is like a very versatile problem because it has more than one solutions. So they tried to brainstorm different ideas, and they were like open to use any software that they know, like MATLAB or whatever. So it was really good or fruitful to see their mathematical thinking. And like there was no pressure that they need to use a software. Like you can do a manual solution of this problem. So, but it's a group project, right? So, okay. So somebody was saying voice is not audible, but it looks like it's audible for everybody else. So it should be fine. So yeah, so try to figure out, like if you cannot find a collaborative project, if you cannot find something, like maybe ask your teachers, like, can you give us a like a working example or something that we can work on or brainstorm our ideas, or maybe some open-ended problem. So give your teacher some work too. they will help you if you ask questions, right? All right, so okay, so we talked about all the strategies, what we should do. We should do group work, we should do meaningful homework, we should explore some, like, because we are on social media, like we spend so much time, right? So maybe out of that 10 minutes, spend on looking for the application of the topic you have done in class. And then, okay, so you have done all this. How can you take your learning to next level? But like how it's going to help you to get a job. So before I talk about that, so at DCIT, we have 90% employment rate within the 6 months of completion of graduation. So, but if you like within 2 years of completion of graduation, we have 98% employment rate. And one of the reasons are that our students have something good to put on their resume. So they do like working projects. They do like in automation program, like they actually create the elevators that go up and down and they can control with their phone, because they learn something hands-on. They have the real skills that people need for a job, right? So whenever it doesn't matter, even if you're doing just like a normal Bachelor of Science or whatever you're doing, it doesn't matter. You can get some skills that you can put on your resume. So translate your skills to a practical use and learn about how those topics are used in industry. What can you highlight on your resume? What is that making you different from your peers or the other people who are in the line for the same job, right? So do you have any extra skill, or do you have like something that you can offer to the employer that other people can't? So I'll just give a very simple example, because I know some of you have just finished your grade 12 and it's just a start of college life for you. So just a simple example. So when we learn statistics, we learn, okay, so we learn easy stuff, like easy things like what's mean, median, mode, standard deviation, right? Measures of variation. And then we go to probability and different types of distributions, hypothesis testing, blah, blah, blah. So we can keep going. So when we learn it, so we learn the theory behind it. So we learn why standard deviation is better than the variance, right? Because it has the same units as the original data. And when we subtract each data value from the mean and we square the values, so we are not just canceling any of the value, we are taking everything into account. So we have to do certain steps in order to calculate the standard deviation. And if we know the form of the formula, theory behind the formula, we have a deeper understanding of the concept. So I'm not saying that theory is not important. Theory is very important. But then after learning that, you need to think about how do professionals use this, right? So think about if anybody is working in a company as a data analyst, like they are not going to do all these calculations manually. So how do they do their works, right? Think about that. And maybe think about if you can develop the same skill. And for that, you need some of the technological skills. And I'll show you, like, rather than doing all this work manually, so we need to learn how to do this work for our exam purposes, because that's how our system is, right? We need to get some grades. But just go one more step, like spend few hours maybe, if like in the summer break, if you have extra time. So think about how I can do this in a quick way that like actually people do on their jobs, because they essentially don't do all these calculations. So now I'm coming to the technological tools, and just coming to the point, like how we can enhance our skills and we can actually do the visualization. We can use different tools for our better math learning. So there are many like tools that are available. Some are free, some are not free, some are really expensive, and some are very easy to use, and some are really complex. So as I just heard that you guys have done a seminar on MATLAB before, so you know that it uses a certain type of programming language, and it's a very strong computing platform. So it helps you to simulate things like you can do so much stuff with MATLAB, but that stuff is not free. So if you are an undergrad student and you don't want to spend so much money or so much time on other like extra resources that you want to use, so I'll tell you some free resources that you can use. Wolfram Alpha is an online, it's just a website. If you just go Wolfram Alpha, if you just Google that, so you will see that people usually use it for like if they want to see a quick graph, or maybe they want to see a quick computation, like they want to do some calculations and they want to check if their calculations are correct or not. So they use Wolfram Alpha. Then Desmos is another one. And that's basically an online graphing calculator, and many students use that. It's absolutely free. And Geometry Sketchpad. So this is basically more than a graphical calculator. So it's an interactive geometric environment. So actually you can drag things on the screen and you can see how the things are changing when you drag a point of a diagram or a graph. So this one is not free. So this is the one I used in my PhD studies to teach very young students. And so from there, I got an idea about GeoGebra. So I don't have any formal training in GeoGebra, but that is another interactive environment, and it's very similar and it's absolutely free. So now I prefer to use GeoGebra over Geometry Sketchpad. So today I'm going to show you a little demonstration about GeoGebra. So these are few tools that you can use even for calculus, so mainly for geometric visualizations. And even for stats, there are many different softwares. So SPSS, that one is not free. And I had one course where I learned SPSS, but I prefer to use the other two that are like, because mostly people have Microsoft Office on their computers, right? If you have a computer, you have like Word, PowerPoint, Excel. So Excel is what we usually teach our students, or what I do in my classes. And RStudio is another free software. It's another stats software that you can use. It's absolutely free as well. It's an open source. So RStudio involves a little bit of programming, like it's like a Python. It's a little bit of coding, but it's not as hard as MATLAB, I think. Because it's a very interesting thing that the first semester I taught at BCIT, I had no idea what RStudio is. And I was given to teach a stats course, and in the lab component, they were using like RStudio. And that semester, I learned RStudio as well as I taught to the students at the same time. So so that's what I'm coming at. Like if you have love of learning, you can learn anything. And these things are not as hard to learn. It's just like you just need to have a little willpower. And I'll just do a little demo on GeoGebra and Excel. Any questions so far? So some of the softwares they are just like apps. Like GeoGebra, you can do on the tablets. You can like it's like if you like on the mobile, I think it doesn't have all the features, but there are some features of GeoGebra that you can even use on the mobile. Okay. All right, so I'll just do a little demonstration. So as I was telling you that GeoGebra is a free tool. It's a dynamic geometry environment, which is very interactive. You can actually move the things around. You can explore different mathematical properties. And even if you don't know what like how to create things in GeoGebra, there are tons of free applets that are available online for exploration. You don't even need to download GeoGebra. You can just do the exploration on the website itself. Like it's like very extensive. And I'll show you, there is a full book on calculus where you have all the GeoGebra applets for every possible topic of calculus. All right, so I'm just gonna switch to, okay, one sec. I'm just gonna switch to GeoGebra. So I'm gonna do a demonstration. So we're gonna investigate some fundamentals of differential calculus. And I think I need to change my screen share because when you change the app, you need to do a new screen share in Zoom. Can you guys see a screen which looks like a graph paper? So Vipul is asking, GeoGebra and Desmos both gives graphs. What's the difference? So I'll show you the difference now when I create things here, okay? So Desmos is mostly like a online graphing calculator, but in GeoGebra, you can actually move things around. You can manipulate on the screen, and it does more. It's like a dancing graph, right? Basically, it's more interactive graph. So let's say I want to create something in GeoGebra. This is what GeoGebra looks like. It's like how we use paint, right? So you create some shapes, you put the paint in. It's like as simple as that. So there are few, like if you just go on all the little tabs here, you can see all the options that it has. So right now I'm just doing in 2 dimensions. You can even do the graphs in 3 dimensions. So this is like the very basic thing that you see first when you go to the screen. Okay. All right, so let's say I'm gonna graph a parabola here. And then I will try to plot a point here. So I'll choose the point tool, graph a point. And let's say I am going to create a tangent at point A to this parabola. So I'll choose my tangent tool. I'll click on the point, and then I click on the graph. So now you see a nice tangent, right? So if I move this point, so basically now this is not a still graph. I can move things around. So if I change my point, it's gonna show how the tangent line looks at different points, right? And you can do more than that. So we see how the tangent line is dancing, but let's say we are interested in knowing what is the slope of this tangent line. So I'm just gonna go ahead and choose the slope of this line. And it shows me the slope of this line. Okay, so the good thing is you can even create some action buttons that actually show you like what's happening on the screen. So let's say I'm gonna call this slope of tangent equals to, and I can either click on that M, or so I'm choosing this M because that's what it has given the name M to my slope. And if I want, I can change its color. Basically, I can make the text a little larger. It's not doing it. Okay. Okay, so I don't know why it's not making my text larger. Maybe it didn't select it. One sec, let's see. Okay. So I bold it, I changed the color. I'm just changing the color so that it's easier to visit, like okay, make it visible to everybody. So do you guys see the slope of tangent here? Like it's big enough to read. And then, so this is slope of tangent. So if you wanna do exploration about slope, like how the slope changes when the function changes its behavior. So if my function is the increasing function, so as long as I'm finding the slope on the increasing part of the function, so I see that slope is always positive. And when my line becomes parallel to the horizontal, slope becomes 0. And when it is for the decreasing function, right? So decreasing part of the function, it's negative. Okay, so that's one exploration that we can do, like how the slope changes its behavior when the function changes its behavior. So it becomes negative versus positive versus 0. And another thing we can explore, so I'm just coming at one of the concepts of our differential calculus. So let's say I draw another point here, right? And another point on our parabola. And if I join these 2 points together, sorry, I shouldn't use a line tool. Okay, let me just delete this. I was trying to do a line segment instead. Can I delete this? Okay. All right, so I don't want this. I want a line segment because I just want to contain it. So this is the line segment AD, right? So line segment is, what is it? We call it a secant line because it's intersecting the parabola at two points, right? So it's our secant line. And I can even look at how the slope of secant line is when point B is at a certain point. So okay, yeah. So this is the slope of secant line. So let's create another action button because we want to see a relationship between the slope of tangent and the slope of secant. And so we can see that how they are related to each other. So when we learn the limiting value of tangent slope is equal to, so slope of tangent is limiting value of the slope of secant. This is what we teach our students, right? When we start with the limit value of calculation, right? Calculus, the limit value. So you can do these kind of explorations with GeoGebra. Like you can actually visualize like how the slope of secant is changing when point B is approaching to point A. So this is what I created for you guys. But if you don't know how to create this, it's all okay. To be honest, I did not had any formal classes for GeoGebra. I just learned it from internet. So, and so so over time, you just get used to it. You just need to find some resources online, and there are tons of resources online. But I'll show you that there are many resources that are freely available. You don't need to construct anything. You can just go there and explore things. Let me just go back to my PowerPoint. Okay, so is it visible, the PowerPoint again? Yes?
Yes, it's visible.
Okay, thank you. So can you guys tell me, like, if you want in the chat, do these two figures have the same volume? Yes? Do these figures have same volume or different volume? So you can say yes or no in the chat. And all answers are welcome. There is no right or wrong answer. Because I always become really happy when my students answer my question. So it doesn't matter if you know the answer or not, if it is right or wrong, but you have the confidence to answer it. So that's the main thing, right? All right, so thank you for your responses. Okay, so if I tell you, okay, so visually, maybe we cannot tell that. But if I give you this information that these two figures have the same height and the cross section at each point is same. And then some of you might think yes. Okay, so let's say we don't know this. So we can always visualize this and see whether it makes sense or not. So again, it's going to take me to a website link. And this is the thing I don't like about Zoom because I really have to switch so many times. Just bear with me 1 second. I have to stop share that and share my other screen again. Here we are. So did you guys see something here? Like this is what it's not working. I'm trying to click on it. It's not clicking. Okay, let's see. It's loading maybe. Just give me a moment, okay? Let's say okay. So this is what I presented to you guys, right? So I can even look at, so think about it, it's like you have a slab and you cut it into different like same triangles. Cross section is same at each side. So when I shift the slabs, so maybe I can put them in a tilting way. Maybe I can like do the shifting, right? And then if I want to see whether they have the same volume, just to be sure, so you can actually transfer the slabs from other side to this side, and you will see that there is nothing that you added from outside. All the material is same, everything is same, it's just holding the same space. So it means the volumes are same, right? You guys agree? So you have seen that, right? So the volumes are all the same. So you can do these kind of explorations online and see if that makes sense to you. So this is basically a mathematical concept. It's called Cavalieri's principle. And it says that if you have something of the same height and the cross section at each point is same, then those two things have the same volume. And since I'm already on this website, so geogebra.org, so that's the website where I'm looking at. So if you go to resources, and it has many different applets that you can explore. And if you just wanna are interested in one particular topic, you can go to calculus if you want to see calculus, and you will be amazed to see that there are so many resources. And one particular, there is a book, it has whole book, book calculus, Tim Brzezinski, and if you click on that, you can see that it has all the possible topics that you have in calculus: mean value theorem, derivative of product, so many things to learn about, right? So you can explore different ideas from there. So it has related applets as well. So GeoGebra is a great tool basically to visualize anything. And okay, so there was another thing. I think that's enough about GeoGebra. Yes, again, so I have to switch back. I'm really sorry, guys. I know it's very annoying for you, but I just wanted to show you the practical, right? So that's why I had to switch, because otherwise I could have just put the pictures on my slides, but I think that would have not done the justice to this, because the beauty of mathematics is that you see actually it in work, right? So this is another example from calculus. So you might know that we do these kind of problems, like volume of a solid when we revolve it around x-axis or y-axis, and sometimes it's very hard for students to visualize what does it actually look like when it revolves about the x-axis, right? So basically here again, so this is an online applet. So on the top you will see there is a function box, and you can change any function here. So if you're doing some homework problems from your book, you can actually type in any function there. It will create the graph for you, and then you can move these sliders for your A and B values, like the limit values, and it will show you the volume here and the bottom, and it won't show you how you calculate it. So you need to do the steps yourself, you need to do the procedure yourself, but actually you can see whether your answer is correct or not. And you can explore, and you can see, you can visualize, what does it look like when you increase or decrease the value of A or B. And I already showed you, there are tons of interactive applets that you can use. Okay, so let's leave calculus, because I think you guys will think that I'm so biased about calculus. To be honest, I don't teach much calculus. So far, I have only taught it twice or 3 times. But I just find it fascinating just when I find different resources. So now I'll move to statistics, and I'll give you another example about statistics. Remember, I told you guys, when we learned about standard deviation or some descriptive statistics. So what we learned in school is formulas and how to do the calculations, how to create a table with different values and then add them, take the square root, divide with n-1 and all that stuff, right? So that's what we are used to. But once you get mastery of that content, so think about how professionals do things in field, right? So this is one of the example from, I think, my mining students. I don't remember. So it's again. So if you have to measure the 30 samples of steel from some steel mill, and you wanna see the descriptive statistics, right? So how the hardness of the steel is, and what is the mean, what is the median of those readings, or what is the standard deviation, how much is the variation in the data, all that stuff. And even if you want to create confidence intervals, the best tool is to do is Excel if you don't want to deal with any coding language. Otherwise, if you are open to learn coding and stuff, then you can even use RStudio. That is another free tool. But I'll just do a little demonstration with Excel if you guys give me the permission, because I know I was given 40 minutes. So can I show Excel demonstration, sir?
Yes, you can carry on, ma'am. I am reading the chat, and the students are enjoying it. So you can carry.
Sorry, because I don't want to bore you guys with 1 hour lecture. So just let me know if you guys want it. I can do it. All right, so I'll just move to my Excel again. Pardon me. I'm just gonna switch. It's a lot of switching, but as I said, it's all worth it. All right, so what I did was the example that I just showed you. So I basically copy pasted that data in an Excel sheet already. So let's say I am a grade 12 student, or maybe first year college student, and I learned some stats concepts, and I already know how to do it manually or using the calculator. And now I want to see how the professionals do things, right? So maybe they use technology, maybe they use some software, because they don't want to spend 10 minutes just calculating average of something. So in Excel, you have many functions like built-in formulas that you can use. So basically, I just typed mean here. So if I want to calculate mean, so I'll just press equal to sign. And I know mean is also called average. So either you can type average, and it will show you the list of formulas that are available. And you can select average, and then you can choose your range of data, like what numbers you want the average of, right? So plug in all those numbers there. So I start from cell A1 and I go up to cell A30 because I have 30 readings. And then I just press enter, and it gives me the mean of all these values. Similarly, it gives me the median. If I just do equal to, for any formula to work, you need to start with equal to. So again, median, you tell the computer that what data you want the median of. And similarly, boom. And so more standard deviation. Okay, so I'll show you standard deviation. So standard deviation, again, I try to type standard deviation. So it has two options, standard deviation P or F. So depending on whether you have the whole population data or just a sample of data. So since I have only samples, so I'll just use F. And again, I'll choose all the values that I want the standard deviation of, because it tells me how much is the spread in the values, right? So how much is the variation? All right, so this is one way of doing it. Did it take too much time? Did it take too much time? What do you guys think? Or was it quick? No? Okay. So what if I tell you I can do even these things more faster? So instead of using each formula individually, we can just get a whole set of values from Excel itself. So if you go to File, Options, and then there is an option called Add-ins. So there is an analysis tool pack. This is a very good tool. So you can just use that add-on. So, okay, so I think I already have in mind. So I just added that add-in. And now if I go to data and data analysis, so it will ask me like what kind of data analysis I want. So let's say we just want, so there are many things like two-way ANOVA, correlation, covariance, F-test for 2 samples. So there's so many things you can do, histogram. But I want descriptive statistics because I want to actually check whether the work I did individually is correct or not. So descriptive statistics, okay. And then it asks me like, what is my input range? So I tell it that my input range is from A1 to A30. Okay, and then it asked me where I want my output to go. So do I want it to go to new workbook or just here? And even if you want to figure out the confidence level for mean, you can do that. So you can set like you want 99% level or 95% level. And okay, so I should tell it where should my output be. Okay, let's say I just run my output somewhere here. And okay, boom. So what do we see here? Okay, let me see if I can make the text a little bigger so that actually everybody can see it. So you guys can see that it has given us so many information just in few seconds. Like what is the mean, standard deviation, sample variance, kurtosis, skewness, confidence level, 95% for means. And like see, like technology is just so great. You can just do so many things in such a little time. But before doing this, you need to know what does standard deviation mean? How do we apply it? Like what are these results, right? So if you just say, hey, I know how to click few buttons on the computer, but you should also know the meaning of the concept. So theory is important, but first you have mastered the theory, go a little further, like learn any skill, see how people do stuff in industry. Actually, I had another example that was on normal distribution, but I don't know if everyone has done normal distribution yet in stats. But again, this is also something that you can do in Excel. Usually when we have to figure out a probability for a normally distributed data, we find the standard score or the Z score, and then we look into the table. So I just inserted a table here. But within Excel, like there is this function called norm distribution. So if you just start typing norm, so it actually asks you like, tell me what the X value is, tell me what's the mean is, what is the standard deviation, and then whether you want like where you want to stop, right? So you just give that, feed that information in the computer, and it will calculate the probability for you. So that's another like great tool that you can use. All right, so I'll just try to wrap it up because it's almost midnight here. So what is the takeaway from today's talk? So it's a simple message that try to take your math learning to next level. Don't feel that math is boring and it's not beautiful. It's very beautiful if you have, if you really want to learn it, if you have love of learning. So try to learn a new skill if you have some time, like when you have weeks off or maybe a month off, when you have a like break, or maybe over the weekend, and highlight your skills in your resume. Like what makes you a better choice over others. So everybody has learned math, but show your employer that how can like you be a better resource for them, like what can you offer to them, right? So again, as I always say, you don't have to spend a lot of money on it. There are many free resources, you just need to find them, and if you have a love for learning and some time commitment, you can learn anything. And on that message, just say thanks for listening for such a long time. I planned, okay, so I won't go over 30 minutes because I don't want to bore you guys, but it just took more than that. And if you want to contact me, so here's my email. And I also do have a YouTube channel that I just started last year when pandemic started and we were stuck at home. And I just wanted my students to have some like personalized lessons rather than just giving them YouTube links. So I don't have many technology, not many, I shouldn't even say that. I don't have any technology related tutorials there, but I'm planning to make some during my summer break because we get 2 months of summer break here in BC.
Thanks, Professor Harpreet. Your talk was very interactive. Your talk is full of visualization, and this is a basic problem in mathematics. Student cannot visualize the things, and you have done the first part, that is inspiration. They will take the inspiration and they will study from Geogebra, and they try to visualize the things. And this is really good. And I want to tell you one more thing to the audience, that last year when the corona breaks and the people were working, teacher were working very hard, and then I was searching a YouTube, and then I saw the video of Dr. Harpreet. She uploaded 88 videos. You can see that videos, and that was a great work. I was really inspired at that time. I was also finding way how to reach my student in effective way. When I look at her video, and that also given me opportunity and inspiration also to do something. And that video was really great. And I want that you must tell the students that from where they can see your videos. And there is also very good news that Dr. Harpreet, our two students, Kanika, she has qualified IIT JAM in 2020 in mathematics, and she also belongs to Himachal. And one other student, that is Vishal, he has done graduation from our college, and now he is pursuing PhD from Carleton University, Canada. And yes, now I request Dr. Bharti for vote of thanks. Sorry, Dr. Bharti, before I end, I may forget the one of the very important member of our Doaba family, Dr. Rajiv Khosla, is also not there because of unavoidable circumstances. He has to go somewhere. I want to thank Dr. Rajiv Khosla. His consistent efforts had made this possible. That he has done great effort for Doaba College. I thank you, sir, in your absentia. And now, Dr. Bharti, you can continue for vote of thanks.
Thank you, sir. Thank you, Gulshan, sir. Good afternoon, everyone. Today we got the opportunity to put our gratitude in words. First of all, on the behalf of Doaba College, we are very grateful to our resource person who accept our invitation.
Dear participant, this is the first step toward that research meant for the students. So in next coming series, we will fulfill what you have written in the chat box. We will try to fulfill your demands or your expectation. And if you have any suggestion, the group we have created, you can share there. And so we'll try to fulfill that in the coming lecture series. Before Dr. Bharti join us, we're waiting for Dr. Bharti. So this your talk was wonderful, Dr. Harpreet, and you have done the very first part very well, and our students are very happy that students that we teach. And basically, this workshop is meant for the student of BSc 1, 2, 3.
Gulshan,
Yes, sir.
There is one student, Vipul Vivedi, wants to say something.
Okay, sir. Yes, sir. Please, Vipul, please say something. You want to say something? Yes. Vipul, you can say.
Maybe he's not able to unmute himself. Please allow him.
Okay,
Hello. Hello.
Yes, carry on, carry on.
Am I audible?
Yes, you are audible. You convey your message.
Yes. So actually, I am right now studying in BSc 2 has been completed. Now next academic year will be of BSc 3. And actually, I have my interest in mathematics, but actually I am not sure in which field of mathematics I should go. In general, I like teaching very much, so I had interest in teaching. But I have listened something that somewhere that in teaching also we have to get term in research as so I'm not sure where I have also started some course in Coursera regarding the data science as well, so I am getting interest in there also, so I am not sure where to go and where not to also. in finance as well. So if anyone can guide, then will be useful.
Dr. Harpreet, can you answer this question that some student want to follow the future that he want to what he want to do? He's not sure. This is the general problem of students. What should they do? Then can you tell us how they follow the higher study in the Canada and guide him for research?
Actually, Gulshan, question is कि वो mathematics में interested है.
Yes, sir.
नहीं पता है कि mathematics की further कौन सी specialization करे कि उसका career अच्छा बन सके. हर ये question है.
Sir, he told he's interested in data science also. Yes, Dr. Harpreet, you can.
Oh, so actually, what I heard, he said like he's also interested in teaching. So, see, I cannot decide for you what you want to do in future, but you see where your interest is. So, if your interest is like overall mathematics, so maybe you can go to teaching. But if just like statistics, like one field, so maybe you should look for opportunities in that field and maybe try to figure out a professional, like some sort of professional like coursework that you can do to get that job. Because in Canada, it's very less, like people don't do general studies as much as we do in India, right? So here in India, everybody does BA, BSc, MA, MSc. So in Canada, people decide that after grade 12, like what they want to do career-wise. So if somebody wanna be a data scientist, they go for like something in statistics field. Like they just do like their studies for statistics. If somebody wanna do accounting or finance or business management, like they start that path after grade 12. So I don't know if I can really help you in this case.
Yes, thank you, Dr. Harpreet. And one more thing, Vipul, I want to add that if you want, if you are interested in statistics in data sciences, and India, there is ISI, Indian Statistical Institute, Calcutta, Delhi. You can go for IIT JAM. As our two students, you have seen that one is a Kanika and other is from non-medical background physics. Both of them have qualified IIT JAM. And you can also qualify the test for ISI also. And then there will be great options there also. In ISI, you can go Indian Statistical Institute of Technology. They take their own exams. So this you can qualify that test and then there will be a lot of options. Is it okay or you want more information? And another thing I want to tell you that you can pursue MSc Mathematics also. After doing MSc Mathematics, you can follow your dream and then you can again by doing UGC, you can come in the field of education, that you can become lecturer or you can say assistant professor in college also. Yes, any more queries? Sir, if you want to say something, Principal Sir?
I would like to invite Harpreet for some kind of faculty development program first. Because first of all, faculty should be trained to use these visualization tools, and after that, that will be a good exercise for all the teachers in this region. And after that, that knowledge can be effectively transmitted to the students.
Okay.
So, if you can
That's my pleasure. Thank you for the invitation. It was lovely to really talk to my own country because I have attended some international conferences, but this is first time ever in India, like my first talk ever in India. So I really feel so happy that I can give in some sort, like I can give something back home.
Please carry on.
Thank you, sir, for your valuable thoughts. And Nanda, sir, can you do the vote of thanks? Dr. Bharti is, I think, having some network issue. So she have left the meeting, I think. So can you do the vote of thanks? Dr. Bharti is there now. Yes, Dr. Bharti, please. Please unmute yourself and then Dr. Bharti, please.
All right, so somebody is saying that if they can get my PowerPoint from my presentation.
Yes.
I'll start my presentation to Gulshan Sharma sir, then he can distribute whoever wants it. So no problem, I can give it.
Okay, Dr. Bharti, please.
Yes.
There's some issues in that one.
Sorry, sir. Sorry,
Yeah.
sir. Good afternoon, everyone. Today we got the opportunity to put our graduate in words. First of all, on the behalf of Doaba College, we are so grateful to our resource person who accept our invitation at such a short notice and for in-depth knowledge that we all have been able to receive today. Thank you, ma'am. Thanks for a wonderful session. We extend our gratitude to our young and dynamic principal, Dr. Pradeep Bhandari, who from time to time motivate us to take new strides. Thank you, sir, to motivate us. We also are very grateful to DBT Ministry of Science and Technology as this event has been able to see the light of the day, all because of their trust and financial support. We also thankful to our HOD sir, Professor Arvind Nanda, for showing his confidence in us. We will ensure that in future also under your mentorship Department of Mathematics will be recognized in more positive light than ever before. Thank you, sir. Next in the list is our overall coordinator of DBT scheme, Dr. Rajiv Ghosla, under whose guidance we have taken the steps to reach the new heights. Thank you, sir. Now it's the turn of Professor Gulshan Sharma, our DBT scheme coordinator, who organized this learning event. Thank you, sir, for arranging International GANIT KARYASHALA. We would like to thank all the members of our Doaba family for their blessings. Last but not least, we are thankful to all the participants from all corners of the country who joined us today. Without your participation, this event can't be successful. Thank you very much to everyone. Thanks a lot.
Thank you, Dr. Bharti, for coming here and giving the vote of thanks. I am also thankful to the participant for taking out time and join this event. And if you have any suggestions, dear participants, for the future webinar series, etc., you can post in group and we will definitely inculcate in the future events. And whatever feedback you have, please give the true feedback. We want true feedback about our workshop and what you want in the future. This is for you. And we want to make our student employable, to make them educated, and so that they can visualize the subjects. I'm really thankful to Dr. Harpreet for taking so much pain. And when I first talked to Dr. Saab, then she's asked about the curriculum. And she asked me first question, sir, is the curriculum is same what you have taught in MSc? I said, no, the semester system has come and the university has devised syllabus into two parts, semester 1, semester 2, otherwise syllabus remain the same. I hope that in coming years, the things will change, syllabus will become dynamic, and that will change according to the industry. And we all peoples, those who are trying hard, and one day will come when India's students will also equals the world. They are doing great work in foreign countries also, just like Dr. Harpreet. And we are proud of you, Dr. Harpreet. And thanks all the participants. And this is from us, from Department of Mathematics. And we are really thankful to all of you, and especially to our principal, sir, who has who listened whole workshop. And this is a great thing, that when your leader is with you, and then you can achieve anything. Thank you, sir. Thank you, sir. Thank you, sir. And this, yes, Dr.
Thank you, everyone. So
yes.
I'm hopeful that I can see you guys in person someday when I come to India.
Definitely, you're most welcome. You may come in India and visit our institution. The principal sir has given you the invitation. You are most welcome. And you can, whenever you visit in Jalandhar, you definitely come to our institution.
Sure, I will. Thank you.
And one more thing, Dr. Harpreet, please keep sharing your valuable inputs with our students so that we can make them abreast with the latest technology. And
sounds good. Whatever I learn, I'll tell you. So yes, we will.
Yes, keep sharing all the things. We are really thankful. Thanks. It's Nanda sir. Can we end the meeting? Sir, can we end the meeting now? Principal sir, can we end the meeting now?
दिल तो नहीं कर रहा पर करनी पड़ेगी.
Definitely. That's so nice to you. Thank you, sir. Okay, goodbye.
Okay.